All right, guys, hopefully you have made your way to Schoology. Again, you can see where I'm at on my screen inside of this Unit 5 folder. This is our current unit. The second to last thing at the bottom says 503 Impulse and Momentum Bumper RA. It says assigned today, but it's not due until after Thanksgiving break in terms of what you're actually turning in. But if you click on this to open it, it has your instructions right here, and it says there are 3 graded portions of this relevant application. The first is a physical bumper that you will complete with your group, and I'm going to talk about all this in a second. The second thing is a digital poster. You can do a Canva, single Google slide. You can do it by hand and take a picture. I don't care, but it does need to be turned in digitally. But a digital poster that must be completed individually. So even though you're working with a group, each of you is going to turn in your own presentation. And the third thing is a data sheet submitted as a group. All project information can be found in the file linked below, and all of you have this link here that says click here to open up the project instructions and rubric. And so you should be able to click that and open up this assignment. So I'm going to talk through that in just a second. But before I get into that, there's some other bullet points here. You must test your bumper under the supervision of your teacher in order to receive a score for this portion of the relevant application. This will be graded in person during the class period on 11/15. That is tomorrow. So you're going to be building today and testing tomorrow, although you can test as you build today as well if you get to a point where you're able to do that. So this is how you get scored for that. Again, there are 3 parts, so there's 3 bullet points. You must turn in your digital poster by clicking submit for this assignment. You can provide a link to your presentation, but you must share it with me first, or attach a file for your presentation. It must be completed individually. If you turn in the same presentation as another student, this will be considered academic dishonesty. Please do your own work. Again, this part is individual. And then the last part is data sheet calculations. You're going to turn this in as a physical copy, and it must be submitted 1 per group. It's to be completed on your own paper, and each group member should complete at least 1 of these calculations. You're encouraged to work together and check the work done by your group members for this portion of the project. And then I'll talk about this in a second, there's one thing in here that says you can calculate or measure it, and I'm going to have you guys measure it. So that one we're not going to be doing a calculation for. There are 2 videos at the bottom on how to connect your computer to the different probeware that we're going to be using for this. You're going to be, basically, let me go ahead and talk about what you're going to be doing. It says you're going to play the role of a vehicle safety engineer who designs and builds cars to help people survive auto accidents. Your group will design and build a structure, a bumper for a car, that will attach to the front of a lab cart and reduce the force of collision. To help you with this goal, you will investigate how well different materials crumple to increase impact time, thus reducing the force of the collision, while still offering protection to the vehicle and its occupants. So again, you're building a bumper, and we're going to be applying the different concepts that we talked about in class. And that's what it says here. Objective, design and create a bumper to reduce the amount of acceleration experienced by a vehicle upon impact, and communicate your results in terms of momentum and impulse via designing a poster. The requirements, this is what I just read to you. There are 3 of them. You're turning in 3 different things. The physical bumper that you're going to test, a digital presentation, poster, whatever you want to call it, that you have to do by yourself, and a data sheet as a group, and then the requirements for each are below. So this is what you're working on today, is the bumper design, and these are the materials available to you for that. Okay, and so it says you may only use the following materials and amounts to construct your bumper. You get a note card, masking tape, paper, cotton balls, disposable paper, Dixie cup, popsicle sticks, and straws. And I do have these materials up at the front of my room, except for the paper. You guys have paper, so that's not up there. But the rest of these things are up at the front of my room. Your bumper may extend no more than 8 centimeters from the front of your cart, which is not a very lengthy bumper. Okay, so just make sure that you're not building something that's too large. Here's your instructions for the poster or presentation, which we're not doing today, so I'm not going to focus too much on this, but please read what needs to be on that. Again, this is the portion that you can work on, and this is really the portion that's not due until after Thanksgiving. Your actual test has to be done tomorrow. Okay, and then your data sheet with calculations, and so again, these are the different things you're calculating. And there's instructions there too, but again, you can't do that until you've collected your data. So your procedure today is to form a group of 3 or 4 in which to work on this project. You could theoretically work in a group of 2 if you want, but I'm going to suggest 3 or 4. Review the rubric on the last page so you're familiar with how the points are awarded. If you scroll to the last page, here is a rubric that shows you the point breakdown on the points for the bumper. It's worth a total of 30 points. The points for your presentation, your poster that you have to make individually, which is worth a total of 40 points. And then your data sheet or your calculations, which is worth 30 points. Of course, that totals to 100. But again, 40 points of it is you by yourself. So make sure that you do your part. If not, you will get a failing grade. If you don't turn it in, the highest grade you can get is a 60 based on the work of your group. Okay, but again, for today, begin planning and constructing your bumper using the materials, ensuring it adheres to the size requirements. Once your bumper is completed, you can measure its mass, convert it to kilograms because our mass is in here, measure in grams. And then add the mass to the mass of your cart to record the total mass in your data table. Again, it tells you that you need a data table up here on your actual poster presentation. It says, hey, you need a data table that contains these things: mass, impulse, time, initial impact velocity, and then values that you're going to be calculating later for impact, acceleration, and force will also go in your data table. Okay, but you have to draw your own data table, and so each of you can be doing that so that you have it for your presentation. And you can do it by hand or you can just do it digitally. Either way, you need data tables so that you can make that poster later on. So make sure that you are recording the data that you measure today and tomorrow. Once your bumper is completed, I just read that one, sorry. Measure your bumper to get its dimensions and then complete a scaled sketch of your bumper with correct dimensions for views from the top and side. Label the sketch with the materials used. Alternatively, you may take a photograph of the bumper with a ruler clearly visible in the photo for scale. So again, all this stuff is telling you things you need to do for the poster. Okay, so although you're building it today, testing today and tomorrow, there are things that you need to make sure you get done so that you have it for the poster that's due later on. And then begin working on your individual presentation that meets the requirements outlined on the previous page. To this point, this is what you should have in your presentation so far by the end of the period today. And again, you don't have to have it done today, but this is what you could have done today in that presentation. And then tomorrow, you're going to be attaching the bumper that you made to your cart. And then it gives you instructions on how to connect to your computer to get data from your Bluetooth cart. You're going to figure out how fast it's going at the collision and then how much force it collides with the force sensor. And I'm going to show you the setup in a second. It's at the back of the room, kind of behind where Andrew is sitting. There is a ramp back there, and that's where you'll be actually testing once you have a bumper built. With teacher assistance, accelerate your cart and gather data for. So once you actually are ready to test, these are the different things you're going to be gathering data for. The instructions, again, on how to set that up. There's 2 videos because one person will need to connect their computer to the physics cart and a different person will need to connect their computer to the force sensor. So you're going to be getting data from 2 different things. And so you need 2 different people's computers for that. That's why you need at least 2 people. You can't do it by yourself. But again, I recommend at least 3. Add the above data into the data table that is in your presentation. Take a screenshot of the graph. Again, you're going to have to put the graph in your presentation, so you're going to want a screenshot of your force time graph, or you can take a picture of it, or you can sketch it by hand if you really want to. And then do the calculations. So again, the rest of this is talking about the calculations that need to be done based on the data that you gather. And then you can include those in the calculations section well, really this isn't of the poster, it's of the data sheet. Okay, so again, rubrics down here, read through it, but let me show you what you're doing. Okay, so this is the physics part that you're going to be connecting to with Bluetooth. And this is a bumper plate that's on the front of it. Okay, whenever this collides, this is a hard surface, it's going to probably bounce and could probably have a lot of force whenever it hits the end of the ramp down there. There's a wall, okay, with a force sensor attached to it. So when it hits, this is going to have a lot of force. Your goal is to reduce that by building something that you're going to attach to this. We can paper clip it on here, tape it on here, use a binder clip, it doesn't matter. But you need to put something at the front of this to cushion the collision, basically. Okay, and again, I read the materials that you have, you can look at it again, but they're up at the front of the room, different things that you can try to put on here. What I'm going to recommend that you do is that you build your bumper on the note card so that the note card can just be taped or attached on here. Whatever you do for your bumper, one thing that you have to make sure to keep in mind is that you build something that, again, meets the size requirements. It can't extend more than 8 centimeters from the front of the cart, but also it can't drag on the track. So it needs to be off the track. If it drags, I'm going to tell you to fix it because that's going to affect our velocity and everything. So it needs to be off the track whenever you run it. So let me show you what this is going to look like with the actual setup that we have at the back of the room. You can turn around. All right, so back here, there is a ramp, and again, we're just going to take this, set it up here, and run it into this wall. This wall is attached to a force sensor that's going to read the force reading. Without a bumper, the force reading is something around 53. I need to run it a few times to get a baseline. Part of your score is going to be based on how much you reduce the force by. Okay, so if you cut it in half, okay, you're going to get a certain amount of points. But I need to get you that baseline number first so you can fill it in. Because down here where it says bumper, you get 10 points if you have a 50% reduction or more. Okay, so if I tell you that it's 50 newtons without a bumper and you get it under 25, you're going to get full credit, 10 points. Okay, if you reduce it at least 25% but less than 50%, you still get 7 points. So it's not like super high stakes. You just lost 3 points. Okay, as long as it does something, you still get 4 points. 5 to 25%, still 4 points. You're only losing 6 points. Okay, the goal, of course, I want you to build something, that works really well, but you'll notice that as long as you build something that works at all, you're only losing 6 points, okay? Because if you have under 5%, it basically didn't do anything at all. So most of your grade is not how well the bumper works. Most of your grade is being able to explain how bumpers work and things like that. So again, you can read through this, but what I need you to do today is get into a group, and you guys probably have groups that you already want to work with that you've already worked with. Maybe somebody's absent. If so, make sure you come let me know, hey, we're going to work with this person whenever they get back. Hopefully they're back tomorrow. But you're going to get into a group and then start thinking about what you want to build, what materials you want to use. You don't have to use all of the materials that are in that list. Like if you're like, I don't really want to use straws, don't use them, that's fine. Okay, but you can use any of the materials that are up there and then construct something that attaches to this. And you're welcome to start testing it out today. If you do want to test it out today, though, you are going to need to watch these videos that explain how to connect your computer to the different sensors so that you can figure out what that force reading is. Specifically, if you just want to test that and you're not gathering all the data today, you only really have to connect the force sensor for that. This one is for the calculations later on. So you will need the velocity for the calculations, but if you're just trying to test it and see how well it works, then you can just watch that video and just hook up the force sensor until you're ready to actually do your final test. Just a heads up, after you've tested it, if your bumper is crumpling, it probably isn't going to work the same the second or third or fourth time, so keep that in mind whenever you're designing it. If you use materials that I've provided today and you want to build a different one that works similarly tomorrow, you might need to bring some materials in for yourself if you start destroying the ones that I gave you. Okay, so just keep that in mind if you plan to run a bunch of tests. Before we get started, does anybody have any questions regarding what it is that you are doing today and tomorrow? No? If you do come up with a question as you're working, obviously, please let me know. But again, today I need you, and it says it in here, to get into a group of 3 or 4 to start working on this project. So that is what your task is right now. Go find yourself a group. If you have questions, please let me know. And again, you can refer back to the information here in the post on Schoology, or of course you can refer to the Bumper Project Google Doc, and specifically the rubric at the end if you're trying to make sure that you're getting full credit.